All right, students, now that you've had the chance to write down the notes, I wanted to take the opportunity to talk through them with you. So let's go through them here quickly. Linear, we said yesterday, means it forms a straight line. And what forces it to form a straight line is that the rate of change is constant. The slope is always up 1 over 1, up 1 over 1, or up 3 over 1, up 3 over 1. The changing factor is always the same. When it's nonlinear, it's not constant. So maybe one time it goes up 1, now we're going up 3 over 1, now up 5 over 1, and it's changing every time. And that would force it to be nonlinear. Remember, the rate of change is our slope. It's the change in y over change in x. So as we look through tables or equations, we look for a constant change or a constant slope. So let's take a look at these first 3 examples that you have written down. We have our x's are being added 1 every time, and our y's are increasing. Every time x goes up 1, y goes up 1. That forces it to be linear. It is constant. That same thing, plus 1, is happening on both sides every single time. That forces it to be linear. The second example, as x increases by 3 every time, y is not doing the same thing. We have plus 3, plus 5, plus 7. If the pattern continued, maybe plus 9. We don't know for sure, but it varies. It's not the same. So we don't have a constant rate of change, therefore making it nonlinear. And for the third one, this one's kind of tricky. As I add 2 to the first 2, it goes down 4. Here, if I add 4, it goes down 8. Now, that might tempt a few of you to put nonlinear, but it's really important to recognize this is linear. If I find the slope, negative 4 over 2, it's negative 2. Negative 4 divided by 2, negative 2. Negative 8 divided by 4, negative 2. It has a constant rate of change. That would make that one linear. And that was pretty tricky. I don't believe there'd be any in your work like that, but I did want to point out that just because they might be different, you really need to interpret the rate of change. The next thing that was in your notes is examples from graphs, and hopefully this was the easy part for today. Has a curve, not linear. Straight line, definitely linear. And this one, kind of tricky again. We have a part that's a line, have another part that's a line, but together it's not a straight line. And so that would force us to say nonlinear. And then from equations. Looking at equations, linear equations, y equals mx plus b. We have to have an x term and a y term. B could be 0, right? And then x and y can't be multiplied, or we can't have powers on x or y. So looking at this first one, we have y equals 4.7. Realize that's the same as y equals 0x plus 4.7. Still linear. 0 is our slope, our constant rate of change is 0. It's always just 4.7, that horizontal line. Here, pi, just a number, it's 3.14. So every time I go up 3.14, I go over 1. I can plot that. And that's the same as saying y equals pi x plus 0. This one, 4 over x. We've never divided by x. That would force it to be nonlinear. Here we could distribute. That becomes y equals 4x minus 4. And so then we have our y-intercept at negative 4, our slope at 4. And so it's linear. Here we have a power, nonlinear. We'll get to the analyzing graphs another day, but for today, the key thing is linear or nonlinear. Linear has a constant rate of change. Nonlinear, not a constant rate of change.